Hello everyone, in this video we will go through review questions for chapter 8. Question number 1. A manufacturer claims that the average lifespan of its light bulbs is more than 1,000 hours. A sample of 30 bulbs has a mean lifespan of 1025 hours with a standard deviation of 50 hours. Does the manufacturer's claim at a 5% significance level? Here, in order to test the manufacturer's claim at a 5% significance level, we first define our null hypothesis, or H0, and alternative hypothesis, HA. Here they claim that the average lifespan of its light bulb is more than 1,000 hours. So the null hypothesis would be average lifespan equals 1,000 hours. And the alternative would be average lifespan more than 1,000 hours. Also here we have sampling distribution with 30 bulbs with mu of x bar as 1025 with a standard deviation of 50 hours. Here we can, in order to test the manufacturer's claim, we can use z-statistics or z-test, and we can simply use x bar minus mu divided by s divided by square root n. Here we can simply plug in the numbers, 1025 minus 1,000 divided by s, which is 50, by square root of n, 30. I'm going to put the final number. Z will be equal to 2.73. In order to get the p-value and see if we can support or reject the null hypothesis, we need to calculate the p-value, which is basically the probability of the z. Here, the probability, as they claim, to be more than 1,000, it means z greater than 2.73. In order to get this p-value or this probability, we can get the z-score, the z-value from the table, z-table distribution, but for the amounts of z equal or less than 2.73, we can look up this z-value on table A2, 2.73 would be this value, 0.9968 would be 1 minus 0.9968, which equals to 0.0042. Excuse me. $32, which is basically less than 0.05, the significance level. So we can conclude that we have significant evidence to reject the null hypothesis and support the alternative hypothesis, that is, the average lifespan of its light bulbs is more than 1,000 hours. Problem 2. A college professor believes that more than 70% of his students pass the final exam on the first attempt. In a random sample of 100 students, 75 passed. Test the professor's belief at the 1% significance level. So again, here we define null hypothesis and alternative hypothesis. The proportion that pass the final exam on the first attempt is equal to 0.7, and the alternative hypothesis based on professor's belief is more than 70%. We have sampling distribution, 100 students, 75 of 100 students, which is p hat, the proportion, pass the test. Simply we can get the z as p hat minus p divided by p times p hat times 1 minus p hat divided by n. That would be 0.7 minus, 0.75, which is this, the sampling distribution mean, minus mean divided by 75 times 0.25 divided by 100. This will, if we do the calculation, we will get 1.15. And if we look up the table, we will have the z-value, or the area, the probability of the z-value as or we can look it up. Excuse me. I forgot to write it down. You can simply look it up. Here we have the z-score as 1 point. Sorry, let me do it again. The probability of z equal 1.15, 1.1, and 5. It will be 0.8749. So I forgot the number. 8749. 0.8749. So if we draw normal distribution, it will be around a little bit higher than z equal 1, So to get the p-value, we need to get this area that we just calculated, that we just got the probability. So in order to, this is the probability that we just got from the table, 0.8749. For the proportion to be bigger than the value, we expect the proportion to fall within this area of the curve. So we have to subtract this probability of 1, which equals 1 minus 0.8749. It equals 0.125. Is this value less than significance level of 1%? No. Therefore, we do not have significant evidence to reject the null hypothesis. Therefore, we fail to reject the null hypothesis. Question number 3. The average weight loss for a certain diet plan is claimed to be at least 8 pounds. A sample of 25 participants had a mean weight loss of 7.5 pounds with a standard deviation of 2 pounds. Test the claim at the 10% significant level. Here again, we first define hypothesis, null hypothesis, and alternative. Here, null hypothesis would be diet plan is claimed to be at least 8 pounds. So null hypothesis would be diet, the average weight loss, equals 8 pounds. Alternative would be the average weight loss at least 8 pounds. It's more than 8 pounds. Here let's check the number of participants. N equals 25. Mu for the sampling distribution equals 7.5, and S equals 2 pounds. Here, therefore, we are going to use t-statistic. T equals x bar minus mu divided by S divided by square root n. Simply, we can plug in this value. By mu, I mean mu x bar. Sorry, I forgot to put that on to the sub. Put the sub here. So it will be 7.5 minus 8 divided by 2 divided by square root 25. The final value, if we calculate it, it would be minus 1.25. If we expect to have average weight loss more than 8, t statistic have to be less than t minus t critical, and we can get the t critical for n equal 25, which means degrees of freedom is 25 minus 1 equals 24. At significance level of 10%, alpha equals 0.1. We can simply go to the table and get the t-critical for these values of n and alpha. For n equal, for df equal 24, it's a one-tailed test at 10% significance. It will be 1.318. And simply, we will consider the negative value. Minus 1.318 as the t-critical. So is the calculated t falls within rejection region? So basically it is minus 1.25 less than minus 1.318. No. Therefore, we do not have significant evidence to reject the null hypothesis. Therefore, we fail to reject the null hypothesis. Therefore, we can support the alternative. So therefore, they claim of average weight loss to be at least 8 pounds might be a possibility. So we have evidence to support the alternative hypothesis. We can basically support the HA. Question 4. A car manufacturer claims that its new model has a fuel efficiency of more than 30 miles per gallon. A sample of 15 cars showed an average of 29.5 miles per gallon with a standard deviation of 2 miles per gallon. Test the claim at 5% significance level. Again, null hypothesis would be fuel efficiency more than 30. So fuel efficiency equals 30 miles per gallon, and H alternative is fuel efficiency more than 30. Here, a sample of 15 cars, n equals 15, showed an average mu x bar 29.5 miles per gallon with a standard deviation of 2 miles per gallon. Test the claim at 5%. Z is greater than 30. So here we can calculate the Z, the probability of fuel efficiency bigger than 30. So here we simply calculate the Z as 29.5 minus 30 divided by 2 divided by square root of 15. This equals minus 0.968. We can get the Z value. And in order here, like I said, this will fall. a little bit close to sigma equals -1 here. We have to calculate 1 minus this probability, z equal minus 968. We can get this. Oh, basically it's we have n equals 15, which is a very small sample, so it basically is a t-value. Excuse me, it's a t-statistic. So which it has the same formula, but we have to use the t-table, and we can get the t-value, but we're not going to get 1 minus the t-value. We just get the t-critical for significance level of 0.5%, and DF equals 50 minus 1 equals 14. T-critical would be -1, 761. Here we got the t as this value. This is the t that we calculated, and this is the t, the critical t, -1. For example, it's very close to -2, sigma equals, excuse me, t minus 2. It will fall somewhere here. This will be the rejection region. So this t is not falling in the rejection region because it's not less than minus 0.968 is not less than 1.761. Fail to reject the null hypothesis. A software company claims that more than 90% of its customers are satisfied with this product. In a survey of 200 customers, 185 reported being satisfied. Test the company's claim at the 2% confidence level. Again, let's calculate. Let's get the null hypothesis and alternative hypothesis. Null hypothesis is 90% of customers are satisfied. 90% satisfied. Alternative would be more than 90.9%. 0.9 satisfied. In a survey of 200 customers, n equals 200, 185 reported being satisfied. P hat equals 185 divided by 200. We can get so we have a large number. We can calculate the z using this formula, p hat minus p divided by, square root of p hat times 1 minus p hat divided by n. Simply, we can get this value, this proportion as 0.925. So here 0.925 minus the proportion in the hypothesis, 0.9 divided by 0.925 times 1 minus 0.925, which equals 0.075 divided by 500. N equals actually 200 divided by 200. Final answer would be 1.388. So we can calculate the T critical. We can get it, actually, we can get the T for, excuse me, this is a Z value, sorry. So here we can calculate the Z. C0 here, sigma equals 1. Sigma equal to 1.388. So this Z this is actually the probability for Z greater than 1.388. In order to get this, will be this area. In order to get less than this Z value, 1.388, we can subtract 1 to get the p-value. One minus p at Z equal 1.388. It will be 1 minus, we can go to the table and get the Z value for at this, and get the probability at this Z, which is 0.962. This equals 0.0838. This value is not less than the significance level of 5%. Therefore, here we failed to reject the null hypothesis. Therefore, we have evidence to support the alternative hypothesis with 90% of its customers, with 90% of customers being satisfied, more than 90% of customers being satisfied. Question 6. The mean height of a certain plant species is believed to be less than 18 inches. A sample of 20 plants has a mean height of 17.5 inches and a standard deviation of 1.5. Test the claim at the 1% significance. Again, here we write down the null hypothesis and the alternative hypothesis. The mean height equals 18 inches. Alternative is the mean height is less than 18 inches. For samples of 20, n equals 20, with mu x bar as 17.5, standard deviation of 1.5, test the claim at 1% significance level. We have a small sample size, therefore we're going to use t-statistic. Using this formula, x bar minus mu, 17.5 minus 18 divided by 1.5 divided by square root 20. The final number would be minus 1.492. This is a t-value. So if you go to the table again and get the t-critical at df equals 20 minus 1, 19. Alpha significance at 1%. Again, it's a one-tail t-test at 10% and 19. Will be t, the critical t would be it should be a minus value. Let me double check. Excuse me, at 1%. 1% would be the other column. Basically this column. Minus, you will, since we're looking to a negative value, we will use the negative value of the same number. T critical is equal minus 2.539. So in order to reject the null, our calculated t has to be less than this value, minus 2.539, and we got t as minus 1.492. Is it less than this value? No. It's actually not falling in the rejection region. It is not less than minus 2.539. Therefore, we fail to reject the null hypothesis. So basically, we can support the alternative, and the average height is less than 18 inch. Question 7. A company states that the proportion of defective products is less than 5%. In a sample of 500 products, 20 were found to be defective. Test the company's claim at a 1% significance level. Again, null hypothesis and alternative hypothesis are first thing to write down. Less than 5% proportion of defective products. So proportion of defective product equals 5%. Alternative hypothesis, it will be the proportion less than 0.05% or 0.05. For number sample of 500 samples, 20 were found to be defective. So p hat equals 20 divided by 500 equals 0.4. Here we can get the z as p hat, which is 0.4 minus proportion 0.5 divided by p hat times 1 minus p hat, which is 0.96 divided by 500. The final amount equals 1.14. And if we go to the z table, here we have z as 0, 1. It will be somewhere here, 1.14. And if we go to the table, we can get the p value, the p at 1. Z equal 1.14 as 0.1271. Proportion less than 5%, so it's already this area. Therefore, p-value is the z, the probability for the z at this score or at this value, which is 1.271, which is not less than the p-value, the significant level at 1%. Therefore, we fail to reject the null hypothesis. Therefore, we can support alternative hypothesis, and where less than 5% of products happen to be defective. Problem 8. A teacher believes that more than 75% of her students complete their homework on time. In a random sample of 80 students, 60 completed their homework on time. Test the teacher's belief at a 5% significance level. Again, null hypothesis and alternative hypothesis. More than 75% of her students completed on time. So on time students equals 75%. Alternative says it's more than 75%. In a random sample of 80 students, n equal 80, 60 completed their homework on time. P hat equals 60 over 80, which is 75. Here we can get the z value for the proportion. 75 minus 75 divided by square root proportion 0.75, 0.25 divided by n, 80. Here, denominator equals 0. The whole fraction will be 0. And z at 0, we know it will be 50%. We got the p-value as p as z equals 0. Which is 0.5 and is not less than the significance level of 5%. Therefore, we fail to reject null hypothesis, and we can support the alternative hypothesis that more than 75% of the students are on time. The question 9. The average time to complete a task using a new method is claimed to be less than 40 minutes. A sample of 18 tasks has a mean completion time of 38 minutes with a standard deviation of 4 minutes. Test the claim at 5% significance level. Again, null hypothesis and alternative hypothesis. Completing the task is at 40 minutes. Completion equals 40 minutes. And alternative completion is less than 40 minutes. A sample of 80 tasks has a mean completion time of 38 minutes. N equals 80 of the sample distribution. Mu x bar equals 38 and S equal 4 minutes. We can use T statistic. 38 minus 40 divided by 4 divided by square root 18. The final value equals minus 2.123. We can also get the T critical and get the rejection region at DF equals 18 minus 1 equals 17 and alpha at 5% and see if the calculated T is actually the T critical. If we go and get the T for this DF and alpha, it would be minus 1.740, and we simply see our calculated T is less than the T critical, or basically it falls within rejection region. This is T at this alpha is 1.740, and the calculated T will fall in the rejection region. Therefore, we have taken evidence to reject null hypothesis, claiming that this task takes 40 minutes to complete. Question 10. A company claims that the average salary of its employees is more than $50,000 per year. A sample of employees has an average salary of $52,000 with a standard deviation of 5,000. Test the claim at the 1% significance level. Again, null hypothesis, A0, and alternative would be the salary is more than 50,000, salary equals 50,000 per year. Null hypothesis is salary is more than 50,000. Sample of 50 employees has average of 52,000 per year with a standard deviation of 5,000. Here we have a large sample size. We can get the probability using Z, or we can test the hypothesis using Z statistic. Mean of X bar or 50,000 divided by 5,000 divided by square root 50. This equals the final value would be 2.828. We can get this area since it's very close to 3. Sigma equals, sigma as equals 3. It would be over 99%. So we need to calculate 1 minus P at 2.828, which is 0.9976. It will be the p-value equals 0.0024, which is less than 0 at 1%, 0.1. This is the probability that we calculated as 0.9976. And this is where the Z for the average falls. Therefore, we have significant evidence to reject the null hypothesis. We can claim the alternative hypothesis, claiming the average salary of employee being more than 50,000 per year is not supported. Thank you so much. We'll see you in the next video.